Good morning, my dear students. My name is Twayna. Currently, I am available at the Hamlet Tuition Center, Brahmatol, Kathmandu, and the Kumudini Secondary School, Kalimati, Kathmandu. My dear students of grade 9, this is your science class, and in your science class, we have been discussing about the lesson electricity and magnetism. After our previous class, we have finished all the parts related to electricity. Now we are going to deal with magnetism. Okay, the first title in magnetism is magnetic field. Well, you already are well acquainted with magnets. Yes, magnets are any objects that attract iron toward itself. Okay, any object that attract iron or cobalt or nickel. Okay, so these magnets have certain field around it. Okay, a magnet cannot exert its force into infinite direction, isn't it? A magnet cannot exert its force in infinite direction or infinite distance. Yes, so there are certain space around magnet in which you can feel the magnetic field, you can feel the magnetic force. Okay, there are certain space around a magnet in which you can feel the magnetic force. Yes, like if you keep a magnet on your table, can it attract a nail which is around 2 meters away or which is at the another corner of your room? Now that's not going to happen. Only up to certain distance the magnet will attract the iron piece, isn't it? So basically magnetic field is the space around which the force of magnet can be experienced. I need to improve my grammar here. The space around the magnet within which the space around the magnet within which the force of magnet can be experienced is called magnetic field. And strong magnet has larger magnetic field, while weak magnet has smaller magnetic field. This is obvious, isn't it? And in magnetic field also, inside magnetic field also, magnetic force cannot be felt at every point. Okay, like you can see here in this diagram, you can see here this is a magnet and this is the magnetic field around this magnet, but you cannot feel magnet in each and every point. Like here at this point, at the black points you will not feel magnetic field, but in blue point you can feel magnetic field. So basically the magnetic force it runs in a curved line which starts from north and ends to south. Okay, the magnetic force runs in a curved line. Okay, so outside the line of force, I'd like to call this line of force, isn't it? The line through which force runs, isn't it? So this is line of force. So outside the line of force there is no magnetism. Okay, outside the line of force there is no magnetism. So magnetic line of force, you can say magnetic line of force is the line through which magnetic force flows or moves. Okay, so the magnetic line of force, the magnetic field originating from a point on north pole always moves in a curved line toward south pole. So at any point in north pole the magnetic force starts. A magnetic force starts at any point in the north pole. Okay, and that force runs through a curved line, and that curved line ends toward south pole. Yes, so the line through which the magnetic force moves within magnetic field are known as magnetic line of force. Okay, magnetic line of force. Any confusion? Okay, basically magnetic line of force is the line through which magnetic force moves within a magnetic field. Know that outside the magnetic field there won't be any magnetic line of force. Okay, well, now you understand what is magnetic field and what are the magnetic line of force, okay, then you need to know the properties of magnetic line of force. It says all magnetic line of force, they always start from north pole and end in south pole, the first property. The second property, they are continuous closed curve. You can see it is always continuous, it is never broken at some point, okay. The magnetic line of force is never broken at any point, it is always continuous. Yes, and then they never intersect each other. This is because the magnetic line of force repel each other, okay. One line of force repel another line of force. That is why you can see near the pole where magnetic force is strong, near the pole or at the pole where magnetic field is strong, the magnetic line of forces are so compact, isn't it? But as it moves away from magnet, they move farther from each other. The distance between each magnetic line of force keeps on increasing, okay. That is why they spread far, but they become weaker as the magnetic line of force divides, or as the magnetic line of force move far from each other, the magnetic field becomes weaker, okay. And near the pole where magnetic field is very strong, the magnetic line of force, they remain near to each other, and yet they never intersect each other, okay. These are the inherent properties of magnetic line of force. They never intersect each other, and they always repel each other. They repel each other and they never intersect each other, okay. And that is the reason why they are crowded near the poles and dispersed at other part. As you move away from the pole, they are dispersed. And in the central part of magnet, you can see they are extremely weak, okay. The magnetic field is extremely weak near the center. Yes, weak in the sense that look here, the same number of magnetic line of force are crowded in this much area, yes, and that same number of magnetic line of force are crowded over or spread over larger area, isn't it? यहाँ जति magnetic line of force छ नि यो सेन्टरमा सरी पोलमा, यहाँ जति magnetic line of force छ त्यति नै magnetic line of force यहाँ सेन्टरमा हुँदा 80 पार्टमा डिवाइड हुनु पर्यो, स्प्रेड हुनु पर्यो, हैन? जति स्प्रेड भयो त्यति नै वीक हुने हो नि, हैन र? बुझे है? Okay, so what you need to understand from here, you need to understand what is magnetic field, what are magnetic lines of force, and what are the properties of magnetic lines of force. Okay, next is terrestrial magnetism. Well, terrestrial stands for the land, okay, and in this case terrestrial denotes the earth. Yes, the earth itself is also a huge magnet. The earth itself is also a huge magnet, okay, and the magnetism of the earth is known as terrestrial magnetism, okay. The magnetic properties of the earth is called terrestrial magnetism. The earth itself is a huge magnet, and this phenomenon was discovered by a British scientist whose name was William Gilbert. He found it out in 1600 AD. Okay, that is altogether now is 2020, means 420 years. Around 420 years ago, the British scientist William Gilbert discovered the fact that Earth itself is a huge magnet, and it has its own magnetic field. And on what basis did he say that? Did he claim that? That we will study in our further classes. Okay, now you got this point. The Earth itself is a huge magnet, and just like a magnet has its own magnetic field and magnetic line of force, Earth also has its own magnetic field and the magnetic line of forces. Earth also has its own magnetic field and magnetic line of forces. Okay, and here in the properties we say that magnetic line of force always start from north pole and end in south pole. See, it starts from north pole and end in south pole. And here in earth also the magnetic line of force start from north. Okay, you see some disturbances here. I feel the disturbance. Okay, what do you see here that disturb you or that is disturbing me? Definitely there is something that is disturbing both you and me. What do you see here? Well, I said that magnetic line of force, they start from north pole and end in south pole. But here saying that shouldn't it start from here? This is north pole, isn't it? This is north pole as you know it, and this is south pole as you know it. It should have started from here, from north pole to south pole. But what's happening here? Is there any mistake in the diagram? Well, no, I don't think so. See, the magnetic line of force is starting from here. Yes, it is starting from south pole of earth and it is running toward north pole of earth. It suggests the fact that the north pole of magnetic earth, that we also refer as magnetic north. Okay, the north pole of magnetic earth or the magnetic north pole of the earth is actually at the south. Okay, that is the fact. Yes, that is the fact. The north pole of magnetic earth or the north pole of the magnet of earth is in south, and south pole of the magnetic earth is in north. Geographic north and south is just opposite to magnetic north and south. Okay, geographic north and south is just opposite to magnetic north and south. Now let me draw a diagram of magnet of earth. Okay, let me draw this. Okay, suppose this is the magnet of earth, this is the magnet of earth, suppose. Okay, just suppose. Then although the north pole of earth is up here, the north pole of magnet is down here. So what I need to write here, okay, let me write it, N. It's not working. Okay, are you getting this? Are you getting this or not? This is quite fascinating, isn't it? Isn't this fascinating? This is just something new that you have studied today. Yes, this is something new that you have studied today. Yes, okay. Well, the north pole of magnetic earth or the magnetic north pole of the earth is in the south pole, and the magnetic south pole of the earth is in north. They are just opposite, the north and south. Magnetic pole and geographic pole are just opposite to each other, and it also makes sense. It definitely makes sense, because if you hold a compass or if you suspend a magnet freely, then what happens? You all know this. Yes or no? You all know what happens when you freely suspend a magnet. Let me draw a compass needle here. Okay, suppose this is a compass needle. Okay, and in compass needle I think there are two points are used, isn't it? One of which is red and one of which is blue. Okay. A compass needle is something like this. Yes, the red is north and blue is south, isn't it? Red is north and blue is south. Yes, okay, it is like this. uh, okay, this is your compass. Yes, when you freely suspend a compass, or when you hold a compass, what happens? North pole of compass points to north pole of earth. Yes, and the south of compass points toward south pole of the earth, geographic south of the earth. It makes sense. See, why does the north pole of compass needle points toward north? Why is it? Because there is magnetic south pole of earth, and you know, opposite poles, unlike poles of magnet, attract each other. Unlike poles of magnet attract each other. Since south pole of magnetic earth is in north, okay, south pole of magnetic earth is in north, the north pole of compass, it always reacts to south pole. North pole of compass reacts to south pole of magnetic earth. Get it? That's why the north pole of compass points toward south pole of magnetic earth. Yes, and the south pole of compass points to north pole of magnetic earth. And based on the response of compass, we consider this magnetic south, we consider magnetic south to be geographic north. See, I am now using these 2 points distinctively. Okay, geographic north, geographic pole, and magnetic pole. Okay, and the direction where the south pole of magnet shows is referred as geographic south. Okay, and in our usual life, in our daily life, we consider geographic north and geographic south to be actual north and south. Okay, we consider geographic north and geographic south to be actual north and south, but in reality, actual north and south is just opposite. Yes, actual north and south are the magnetic north and south. Okay, but in our life, in our daily life, we consider the response of magnet. We consider the response of magnet in a compass. Okay, that is why we still now consider geographic north and geographic south to be actual north and south. Understood? Do you have any confusion up here? Okay, so based on, due to the terrestrial magnetism, some effects are seen. Okay, we are going to discuss about them one by one, but that is not possible in our today's class. We will do that in our next class. Okay, first of all, the existence of magnetic meridian and geographic meridian, and an angle of inclination or angle of dip, an angle of declination, and neutral point in magnetic field of a magnet. Well, these 4 effects are seen. These 4 effects are seen mainly due to terrestrial magnetism. Okay, let us discuss at least number 1 today. Okay, number 1, existence of magnetic meridian and geographic meridian. Well, in our previous class, in our previous slide, what I said that magnetic north and geographic north are not same, or magnetic south. Okay, magnetic north is here, geographic north is here. Magnetic south is here, geographic south is here. They are just opposite to each other. Okay, now you should know that they are not just opposite, but they are not coinciding as well. You can see the geographic north and geographic south. Geographic north and geographic south are not exactly at the place of magnetic south and magnetic north, or magnetic north and magnetic south. Okay, the geographic poles are not at the same place as magnetic poles. Geographic poles, it is determined by the rotation of earth, because earth rotates around the axis, isn't it? And that axis runs through geographic poles. Okay, geographic poles के को आधारमा डिसाइड गरियो त अर्थ को एक्सिस को आधारमा अर्थ यो एक्सिस मा रोटेट गर्छ भने यो एक्सिस को एक्सट्रीम पॉइंट नै जियोग्राफिक नॉर्थ र जियोग्राफिक साउथ मानिन्छ. ओके, तर म्याग्नेटिक पोल चाहिँ के छ त जियोग्राफिक पोल भन्दा अलिकति पर छ. म्याग्नेटिक साउथ पोल यहाँ छ भने म्याग्नेटिक नॉर्थ पोल यहाँ छ. दे आर स्लाइटली away from geographic poles. Okay, and the imaginary line that joins the poles are called meridian. The imaginary line that joins the poles of the earth are called meridian. So the imaginary line that joins the geographic poles of earth is called geographic meridian. Okay, the imaginary line that joins the geographic pole of earth is called geographic meridian, which is represented by black line here. And the imaginary line which joins magnetic poles of earth are called magnetic meridian, which is represented by red line. Understood? So magnetic meridian and geographic meridian, they exist because of magnetism of earth. If earth was not a magnet, then the magnetic meridian would not exist. Understood? Okay, and the geographic meridian and magnetic meridian, you need to take note on this. We will do this much for today, and rest of the 3 terms we will discuss in our next class. Okay, say existence of magnetic meridian and geographic meridian. The imaginary line joining the north pole of the earth and south pole of the earth is called geographic meridian. It also forms the axis of the earth. And the imaginary line joining the magnetic north pole and the magnetic south pole of the earth is called magnetic meridian. The magnetic pole of the earth is opposite to the geographic pole, that is, north pole of the terrestrial magnet is in the south and south pole is in north. Moreover, magnetic north pole is not exactly at the geographic south pole, but little bit offset. Similarly, magnetic south pole is not exactly at the geographic north pole. So, magnetic meridian and geographic meridian do not coincide to each other. Coincide means खप्टिनु, एउटाको माथिबाट अर्को जानु. त त्यस्तो छैन, they are separate. Okay, opposite of coincide is separate. Any confusion? Okay, so we will do this much for today. Okay, until our next class. Thank you, class.